Good afternoon or good evening, depending on the part of the world, or good morning, wherever you might be. My name is Dr. Ben Chapman. I'm a professor and food safety extension specialist at NC State University, and I'm also the project director for Food CoV-Net. Thank you very much for joining us today. We'll be hearing from two speakers today, speaking about their perspectives on environmental sampling and environmental monitoring for SARS-CoV-2 in food environments. And what I've asked our speakers to talk about today is really focusing on just their insights and things that they're thinking about, and sharing any of their experiences over the last 18 months in this area. Just as a brief introduction, Food CoV-Net is a multi-university and multi-stakeholder project. Our group is funded by USDA NIFA to investigate and focus on coming up with solutions, conducting outreach in the areas of SARS-CoV-2 and COVID-19 in the food sector. Our project includes collaborators from not only NC State University, but also University of Florida, Rutgers University, and the University of Nebraska-Lincoln. We have multiple groups that interact with us on a monthly basis. And in fact, that's where this topic came from, was one of our stakeholder groups who is largely made up of industry and regulatory personnel, really asking us to try to facilitate a discussion about how do we view the area of environmental monitoring as now, and what did it look like over the last year, and what do we see going forward. We have two just phenomenal speakers joining us today. So our first speaker is Dr. Mansour Samadpour. And Mansour and I have interacted quite a bit over the last decade or so in lots of different forums. But he received his BS and MS and PhD degrees from the University of Washington. After completing his PhD and postdoctoral studies, Dr. Samadpour became an assistant professor in the Department of Environmental Health at the University of Washington. In 2001, together with Dalia Alfi, he started the Institute for Environmental Health, IEH Laboratories and Consulting Group. He's an expert in epidemiology and pathogenesis of foodborne and waterborne pathogens, the transport of microbes in the environment, and food production systems. Mansour and his group at IEH has really been at the forefront of the discussions around environmental sampling and environmental monitoring. And so we'll start things off with him. Before I pass things over to him, just a little bit of housekeeping. If you have questions as an audience member, there are two ways to get those questions to our panelists, either using the Q&A function in Zoom or by using the chat function. I'll moderate a discussion after some prepared remarks from both of our speakers. After Mansour speaks, another speaker, John Donaghy from Nestlé, and I'll do a more formal introduction of him as we go along here. So Mansour, I'm going to stop sharing my screen now and pass things over to you.
Thank you so much. Let me see if I can share my screen. Okay. Okay, I'm going to start by going over the events and how we got into developing an environmental monitoring for SARS virus, for COVID. Let's start with January. we have an R&D group in Seattle, and that's where we develop our test systems. So in January, I decided to start a working group on for the COVID response. So got a group of scientists together, and okay, you guys do literature review, identify potential methods, do the bioinformatics. Another group was keeping track of the EPI and public health response in US and in Europe. At that point, kind of like, we knew that it was going to get big and out of hand, and lab capacity was going to be an issue. So I had a discussion with one of the two main regulatory agencies in the US. And the topic was that we need to be doing a lot of testing and the capacity isn't there. Is it possible to relax the rules and allow ISO 17025 labs to be able to do human testing? So, you know, they were interested enough to take it to the top and kind of like have discussions with another agency. At the same time, kind of we started to buy more PCR equipment. We knew that we need to set up shop, so immunomagnetic separators, and we needed to support our client base. So through our channels, we had several containers of masks and swabs and laboratory disposables and chemicals. So we ordered tons of things through our main purchasing group in Seattle and through the distribution companies that we own. Something that has helped me kind of like foresee these things is when I was younger, you know, I kind of like lived a few years in a war economy in Iran, and I knew very, very fast, very soon, everything is going to become scarce. So in February, we heard back from our contacts in the first regulatory agency. And so they had a meeting with the second regulatory agency during their monthly meetings. They had a discussion about this proposal. And the second regulatory agency did not see a problem, and they didn't see that we're going to need extra capacity. So we were kind of on our own. Same time from Germany, our labs in Germany were told that they can start setting up for COVID testing. Germany actually allowed food labs to start doing human testing. So we started doing a method development for SARS-CoV-2, started to apply to get CLIA certification for our lab in Seattle, because that was the only way that we could process human samples. And as a backup to that, started looking to buy a clinical lab should, you know, kind of we get trapped in the regulatory red tape. And we started having webinars for the industry to have technical discussions with our client base regarding their COVID response. To our surprise, it actually took State of Washington 2 weeks to give us the approval for our CLIA application. You know, we already had quality systems, and they considered all of those. We had adopted the CDC method for SARS-CoV-2 detection, and based on that, we developed our method, and we still had to file with FDA. And because it was a method that we had in our lab, State of Washington gave us permission to use it. And we started sharing reagents and methodology with our labs in Germany also. In March, we we talked to our client base and we told them that we discussed that now we can do COVID environmental testing, discussed the pros and cons, developed test kits for them, and they had started actually sending samples. One of the issues in any one of these ventures is, you have to make this viable for the client industry. And, at the time, the COVID test, the kits that you had to buy were $25 to $30. Would take another $15, $20 of auxiliary stuff to buy to be able to do the test. By having our own test kit system, and we also had our own RNA extraction methodology, and we manufactured the silicon magnetic beads in-house. So we managed to bring the price down, and we offered the test at $75 to our client base and $85 to non-client base. About a month later, another lab started offering the same test for environmental testing for $300. Then a couple of other labs kicked in, and the price dropped to somewhere around $110 to $130 for them. But cost is always something to consider. After a few months of doing this testing, we started to gather the data to be able to have a publication and share the learning with the industry. And this is the paper, Prevalence of SARS-CoV-2 Contamination on Food Plant Surfaces. The reason that I started doing this, and I thought and envisioned having an environmental test kit having utility, was not because I was worried about contaminating food or food contamination. The reason was that I wanted to see, kind of environmental monitoring to me was the best way to assess whether we have human contamination when we have infected individuals in a plant. So I was pushing this as a surrogate. And what I was telling my client base was that let's do this. If we have hits, then at that point you need to start testing, because a lot of companies didn't want to test their personnel. So today, as you guys know, 157 million, 158 million infections have been reported. So the real number is probably many folds above that one. These are people that have actually tested positive and have been tested. And but 3.3 million deaths have been reported. And there are reports that all of these are undercounted severely, and the number of deaths are far more. Even in the US, they're saying that it's more than close to 1 million instead of 500,000. Since then, we have learned, from very beginning, what again we were telling the industry and all the scientists were telling when we were talking about the virus, is that it's an envelope virus. It's environmental. Survival is not as much as non-envelope viruses. It's, it gets inactivated easily. However, it is possible to detect it in the environment, and that was the purpose. It's believed that it does not transfer easily through touch. Someone has to be heavily contaminated to contaminate the doorknob, and if someone immediately reaches and take that, touch that, then and then touches his or her face, it's possible to have transmission in situations like that. In food industry, in April 2020, 130,000 people were tested, 3% tested positive. And some food plants had rates of positives as high as 43%. The data shows that most of the people impacted were ethnic minorities. Again, a lot of this work was done in beef plants, in meat plants, and that's the usual composition of workers. And one reason that, in these plants we had a lot of transmission is because of the distance between workers, and lines are extremely crowded, as you guys know. So from March to September, we were doing this work, and included 116 food production facilities, 22,643 samples that were taken and sent to us for analysis. In one situation, the environmental monitoring indicated a high level of contamination. And after speaking with the management, they immediately started testing. And we did 1,248 samples from the same establishment. And we'll show you the data later. So we had put these test kits together. So every kit had a swab and had a viral inactivation media that we had formulated. So they would wet the swab in a separate tube that had a wetting reagent, and swab the area, then transfer the swab into the second tube, which was viral inactivation. At that point, if they had a viable viral particle, it would get inactivated, and they would then send those to us. Would come to the lab, we do RNA extraction, and using magnetic beads, we would concentrate the extracted RNA, and then that would go to the PCR reaction, reverse transcriptase, PCR real time. And if they had the CT value was below 40, this was considered to be positive. And same thing with clinical specimens, they would follow the same route. 1.23% of the 22,643 samples were positive for the viral genome. And as anticipated, frequently touched surfaces had the most contamination. Welfare areas, 1.36% positive. And this is on an average of all the locations. So depending on the plant and then how many positives they had, and if they had high level of positive humans, we would see higher levels, of course. Bathrooms, lunchrooms, locker rooms, a lot of positives. We did not do the production areas. So we did welfare areas and then the office areas. So 1.33% positive, conference rooms and offices, training 0.38. One plant had the receiving area was sampled and was heavily contaminated. Building entrances, hallways, 38 of 2,439 samples were positive, 1.56%. And like any other study, you know, there are some locations send samples and don't specify the area. So there were some that we could not determine where they came from. Computer devices, but you have to have in mind that you know, some plants where they were doing these things, you know, they had an infected individual. So we have 7% positive. So these were probably more targeted sampling. Chairs and benches in break rooms, in locker rooms. Really interesting one was sanitizer dispensers, because that's something that everyone touched. So at the point where they were pushing the lever down, you know, we had like 6% positive. Bathrooms, break rooms, entrances, locker rooms. Those are places where they had the dispensers. Doorknobs, door handles, heavily contaminated. Rails, you know, light switches. So practically time clocks. So practically, you know, all high touch point areas, and those were the places that people were sampling. So 54% of the plants, 46% of the plants had 0 positives. So this is where we are looking at, you know, how many positive hits we had in each plant. 3% of the plants had between 10 to 30% positive. So that this is a good breakdown of what we saw. And in all of those, you know, they had active, you know, infections, and they were monitoring and testing and taking actions. I should also say that at the time when they started doing environmental monitoring, you know, a lot of precautions had already been in place. Social distancing, you know, putting, you know, reducing density in areas, in break rooms, having break rooms outside. So a lot of things were done, you know, continuous sanitation of surfaces. So every single establishment that we were working with, we had all of those precautions already in place. So we looked at a trend among the plants. Plant A, as you see, there was a peak. And then after that, more or less, once they knew that they had an issue, then, you know, kind of, they managed to control it. And same thing with establishment E. So, you know, we have high levels and numbers go down. And then you see, you know, like if you look at the establishment C, for example, you know, they had just numbers kept going up and down. And same thing happened in establishment D. This is all reflection of number of positives in the community, which ended up in the plant. So different waves would come in, or different levels of contamination working into the plant. So this was a situation in this particular plant where we had a very high rate of environmental positives. And they immediately tested, and we also had a very high rate of positive among their people. But you see that, you know, as the number of positives in the worker population went down, the environmental results also came down to non-detect levels. So conclusions of the studies: frequently touched surfaces, you know, had the most level of contamination. Contamination, when you find it in the environment, in any work environment, that means there are people that are infected, and they need, you need to kind of attend to that, the bigger issue, identifying the asymptomatic and pre-symptomatic employees. So those are the two. The challenge was always, what do we, how do we know someone has COVID? It's not really taking the temperature can just take you so much, can tell you so much. There are people who are asymptomatically infected, and there are people who are infected. They don't have any symptoms, they're shedding, but they're gonna have symptoms in a few days. So pre-symptomatics. Our conclusion was that using this approach is a valuable surrogate to look at the health of the worker population. And once we have hits, then we can start testing or concentrating and do selective testing or universal testing of the employees. I believe that this is just another tool that we have and we can use. There is a time and place to use it. I don't believe that there is need to do this routinely. The other issue that could be of interest is testing of food shipments. We certainly have done that for our clients. Those were all in anticipation, or when they were sending shipments to China. And is this is this needed? Is there a scientific reason to do that? No. Is there a public health reason to do that? Absolutely not. In some cases, it may be a condition of trade. Going through the experience, for us was, I never intended to set up a CLIA lab, but now we have a clinical lab that we intend to continue using and have it, for, we can use it for norovirus, for hepatitis, for other kind of pandemics that may be coming. And it caused us to, put a lot of pressure on us to expand our manufacturing capabilities. We have now expanded to viral detection kits, now doing norovirus, hepatitis, SARS. We had to come up with a viral transport media and get approval for that, which we did. And same thing with the sampling kits. And one interesting side project that came in, kind of like, said, what happened if everyone had, it was possible for people to just like do this type of testing at any time. So I got my engineers together, and we designed and we developed a small, tiny PCR machine. It's handheld and can run any PCR. And we actually developed a COVID test to run on the same PCR machine. So when you go through this type of experiences, sometimes something good comes out of it. So this is one of the toys that we developed. With that one, let's just go to questions and see if.
Great, thank you, Mansour. And I think what we'll do is I'm going to introduce John here, and we've got some questions coming in through the chat and Q&A function, and so we'll hold all the questions until the end of our next presentation. But thank you very much for your insights. So I'd like to introduce Dr. John Donaghy now. John is currently head of food safety for Nestlé in corporate quality management at Nestlé headquarters in Switzerland. He's responsible for setting food safety standards and policies related to microbiological, allergen, and physical hazards for global operations. And that includes over 350 factories in 80 countries. He joined Nestlé in 2011 and has held his current role since 2014. Prior to joining Nestlé, he worked as a government and academic food safety microbiologist, and he is a member of ICMSF, the International Commission for Microbiological Specifications for Food. John, please go ahead, and the floor is yours.
Thank you very much, Ben, and hopefully people can hear me. Anthony, is it okay and people can see my screen?
Yes, sir. It looks good.
Super. Thank you very much. Thanks again, Benjamin. Yeah, just to sort of to add on in relation to the topic today, within Nestlé, within my role, I have the global ownership of a lot of the prerequisite program standards, as everything from HACCP to environmental monitoring, cleaning, sanitation, pest management, foreign body management, thermal processing, etc. So naturally, by being the, let's say, the Nestlé owner of the standards on environmental monitoring and on cleaning and disinfection and on personal hygiene and routines of entry to factories, when COVID came along, it sort of automatically fell on my lap, you know, for good or for bad. So, and I think as Mansour said, we've learned a lot in a year about how to handle something like a virus like this. So today I'm going to give you some insights as to sort of and views on whether I consider there is a need for SARS-CoV-2 environmental monitoring in the processing environment. And just to sort of to put it a little bit in context, when any of us think of environmental monitoring, certainly when I think of environmental monitoring per se, I really think of food safety. What I do environmental monitoring for, and what it is classically known as, it is a means of verifying your food safety programs, be it your HACCP programs with CCPs, or be it your prerequisite programs from cleaning, zoning, etc. And of course, as well as as a verification tool, it also acts as an early warning tool. So in some ways, you know, when we talk about COVID, we're talking about an occupational safety risk, you know, not a food safety risk. So we have to be careful that we don't blur the lines between what is classical environmental monitoring, like for Listeria, Salmonella, Chronobacter, or whatever other organism. And even if I think of some of the foodborne viruses that we know of, for example, Hep A or norovirus, you know, I don't know of anyone who is routinely testing for those organisms as part of their environmental monitoring programs. And one of the reasons why they don't do that is because they view the other environmental monitoring that they're doing for bacteria generally to act as good surrogates for their hygiene that would control some of the other foodborne organisms. And as well as that, the analytical methods for viruses are not as, let's say, robust or not as easy to perform, let's say, as those that you would do for typical hygiene indicators or for some of the pathogens. So really, just to put it in perspective, I want to sort of, you know, put that sort of, you know, thing at the beginning, is that we have to be careful that we do not blur the lines between environmental monitoring as we know it currently and environmental monitoring for SARS-CoV-2. Of course, SARS-CoV-2 and the COVID pandemic has impacted the food industry dramatically, you know, and it's impacted probably all aspects of the food industry, because although it's a community disease, let's say, lots of the community work in the food industry, and lots of the food factories will have large portions of local community. And if I think of even things like farmers, primary producers, manufacturers like ourselves, restaurants, people supplying packaging, a lot of people from the community are employed in various parts of the food sector, and the food sector had to continue operating during the pandemic. And how were they able to do that? Of course, they did that by putting in place all of the various preventative measures that we know about. And I think here what we did in Nestlé, and I think all other food industries and all other industries for that matter and within the community, put in the hierarchy of control in terms of how to control SARS-CoV-2. So right from the very beginning, from a Nestlé perspective, even in February, we were actually then immediately implementing self-reporting. If you're sick, if you had any symptoms, this was because, we had factories in China where SARS-CoV-2, let's say the origins, or that's where the first was reported. So we have factories there. So we knew about this very early on from January, February, and we immediately started to implement various aspects of our preventative measures. The medical reporting, if you felt sick, you stayed at home. If you felt sick and had to stay at home, you were paid for staying at home. If we started to introduce temperature monitoring to see if we could actually detect employees with high temperatures, etc. Even at that very beginning, we were doing a lot of contact tracing. Not by an app per se at the beginning, but even for all our employees, if you come in, you had symptoms, you were sent home, you're asked who you were in contact with at the factory. So there's a lot of in-depth contact tracing right at the very beginning. And then obviously, as we've moved further down the line, we even went to the stage of not only temperature monitoring, but even lateral flow testing of employees coming in. And then, of course, within the manufacturing environment itself, we introduced all of the increased hand sanitization, increased product surface sanitization, high touch contact points that Mansour mentioned. The cleaning of those were really strongly reinforced. We had maybe on a regular basis, within 1 to 2 hours, someone come around, clean every single high touch point within factories, within offices, within administrative buildings, where we had this, as a means of, let's say, protecting, because at that beginning, remember, there was also controversy about whether it could be transmitted from surfaces to individuals through the hands and then the mouth, nose, etc. So we did a lot of this preventative measures. Then, of course, we moved to face mask wearing. At the beginning, there's a lot of discussion. Should you wear face masks? Should you not? There was some information coming from WHO, which at the beginning did not advocate mask wearing. Then we moved to mask wearing. And even then, of course, we moved to social distancing, and ensuring, particularly as Mansour has explained, some parts of the food industry were showing increased numbers or some outbreaks. So, of course, we had to reinforce, as well as everything else that I have in the previous slide, the social distancing. And this was not just social distancing within the factories themselves, but actually where the people were living. We have people who live in dormitories that travel to factories via buses. So we increase social distancing at the dormitories where they live, increase social distancing in terms of the number of buses that we had to put on to transport people to the factories, so that they were separated within the vehicle of transport. Where they clocked into the factory, we reinforced different time slots for when people could clock in and how they queued up to clock in. We didn't want 200 people all rushing to clock in at the same time. Then the locker rooms as well were all segregated to put in place this social distancing. And then within, as you see in the bottom two slides, or the bottom two pictures, even in the canteens and the restaurants, perspex dividers were set up so people were not actually sort of breathing close to each other, that they could transmit it person to person. And where there was no opportunity for them actually to separate, beyond 1 or 2 meters apart, then of course visors, face masks and screens were put in place. So I'm just trying to highlight here at the outset is that we put in place very, very strict preventative measures to really stop symptomatic or asymptomatic or pre-symptomatic people entering into our plants, because we knew this could be a risk. But of course, then we saw in the headlines coming about the outbreaks at meat processing plants, and and the question is, did that justify environmental monitoring? I think if you look at all of the outbreaks associated with meat processing plants, either in the US, in Europe, and elsewhere, there is some unique characteristics, and I think Mansour alluded to it. For example, it is a unique environment. Firstly, in terms of these are cold, wet environments. You have a lot of spraying, for example, hosing maybe down of carcasses. You have a lot of cutting open of carcasses, so you have a lot of utensils, maybe like saws, etc., that are being operated and are actually maybe being shared between employees. So you also have a very noisy environment, so people are having to speak louder, they're having to shout to communicate to each other. So again, you're going to get a lot of transfer through the aerosol route, and it may hang around for longer in these plants. You have people working close together. You also have the nature of the employees are such that they may be transient workers, they may be immigrant workers, they may be living in the same houses, the same accommodation, close to each other and traveling together. And even by the nature of their contracts at times, they may actually not want to report that they have any symptoms, and so they want to come to work. So I think the meat processing plants, to a certain extent, were a very unique part of the food processing industry. And I would say, let's not all look at what happened in the food or the meat processing plants and think this is the same for all other food processing plants or food manufacturing plants or even food retail, etc. And I still have very much of the opinion that a preventative approach, like I say, some of the measures we put in place is better than trying to detect the SARS-CoV-2 virus in the environment. And just to highlight, for example, not only in food processing, we also saw outbreaks in other situations as well. So basically, as I mentioned before, it's a community disease. So basically anywhere where you're going to get groups of people coming together, being in close vicinity to each other, and actually sort of communicating, like, so you get spread by aerosolization, by talking to each other, etc. There is an opportunity for it actually to transmit between individuals. You've seen outbreaks, for example, at the dormitories at schools. Just recently I saw in Ireland, there was an outbreak at a construction site. 85 people at a construction site. Now, I've not seen anybody clamoring to say we should do environmental monitoring in dormitories or on construction sites, for example. So I think this is what we have to bear in mind, that why just the food industry would have to do environmental monitoring, because there has been outbreaks in other situations as well. But of course, then, as it went on, we saw a lot of testing taking place, as Mansour has alluded to, for sure. Clinical testing and testing of individuals became an important part of sort of diagnosing whether some of your employees or whether people in the community actually were positive and actually posed a risk. That was the basis of contact tracing as well. But then obviously that moved a step further to see whether we could do environmental monitoring as part of a detection method for infected COVID workers, for example, coming into processing plants. And I just take some of the quotes from someone who is manufacturing kits and advocating for environmental monitoring, and what they actually say and what I consider what it actually really does mean. For example, in some of the advertising I saw, if swabs yield a negative result, you can be confident that your workplace is clear of SARS-CoV-2. Really? What I say that tells me is, it tells me that no SARS-CoV-2 RNA was recovered and detected from that sample site. So I think we have to be careful about the advertising, because in this instance, you're having a negative result could actually give you a false sense of occupational safety. If you think that I don't find anything, that I'm okay, and there is no people either symptomatic or asymptomatic or pre-symptomatic in your workplace. So you see, we have to be sort of careful about some of the things we advocate. Another point by the same organization had said, if a swab test yields a positive result, this confirms that the infectious virus was on the surface sample, indicating that someone with COVID-19 was in that area. I would beg to differ on that, and I would say what a positive finding, what it tells me is that SARS-CoV-2 RNA, not necessarily infectious, was recovered and detected from that sample site, which may have originated from a person, a processed or a non-processed raw material, or a packaging material. Because, for example, if I find RNA post-heat treatment, what does it actually mean? If I find RNA after an IQF product, for example, has come down a belt, does it mean I have had a positive person in my factory? Not necessarily so. Someone who has harvested the berries or whatever IQF vegetable may actually have contaminated that product before it ever reached me. And so the RNA that I'm seeing actually in my factory has not come from my own factory, but actually has come from someone that delivered my material. Similarly with packaging material, packaging material is widely handled. It is delivered, for example, be it cardboard, be it plastic, be it other polymer material for packaging. It is delivered in large rolls. So you imagine if someone at a packaging plant was positive and some RNA is deposited, I get it in, I test a high touch point surface, which could be packaging. I find RNA. Does it actually tell me anything about who's in my factory that may be positive? So it relates a little bit, and I'll come to it later, about what do I do with the results that I get? How do I investigate the results that I get? Finding RNA, firstly, not necessarily infectious, and secondly, it doesn't necessarily indicate that it was someone within my plant. So I think these are just, let's say, precautions that I put out there in terms of how we interpret the result, either a negative result or a positive result. So then if I look then in terms of what, let's say we should do environmental monitoring for with respect to SARS-CoV-2, I think we're all agreed it's not a food safety issue, and the environmental monitoring is not being done for a food safety reason. But when it is advertised, it is generally advertised as as a means of detecting your symptomatic or asymptomatic workers. Then we can get into, and Mansour discussed it very well, and I'll come a little bit to the paper that he talked about as well. Are we really looking for a needle in a haystack? Are we looking for a small needle in a large haystack when we're actually looking for detecting the number of people that may be there? Mansour mentioned 3% of people in food processing was found positive. But if you're actually, I would hope, certainly in our factories, I would hope that symptomatic workers are not getting through the door. So then we're looking at asymptomatic or pre-symptomatic workers, and that will even be a lower percentage of the total positive. So we're immediately looking at even a small subsection of a subsection of a population in terms of that we're trying to find that they may have deposited something on a surface. And I think you look at the paper as Mansour has just alluded to, and without going into the details of it, I think you will see there you recovered 1.23% of the total that was sampled. And I think Mansour has done a really nice job of explaining the rationale behind the paper, etc. Some of the things I would sort of maybe ask questions in relation to the authorship of the paper. I could say, for example, the survey ran from March until September. Certainly, a lot of the preventative measures that we talk about were really only starting to kick in. The real thorough preventative measures, along with testing of workers, was only really starting to kick in from about the summer onwards of last year. About March, April time, people were thinking, what should we do? Yes, of course, they were trying to stop workers coming in by measuring their temperature. They were doing a lot more disinfection of surfaces, hand disinfection, etc. But I think as the year went on, more and more preventative measures, and people were certainly more aware of the precautions they had to take place, took place later in the year. And I think if you look at the graphs from Mansour's, the paper and what he has presented, you'll see that where you saw the spikes, they were generally about May when you had the highest levels. So really, I would argue that perhaps what we saw is maybe the worst case scenario, where at the beginning of the monitoring program that took place. And also, Mansour also talked about, for example, one of the facilities where you had a high environmental load, there was good correlation between that and where the workers were found. But, if you look at some of the ones where there was low environmental load, what did that tell us? You know, again, I go back to, am I looking for a needle in a haystack? You know, and even though here we find 1%, about 1% in average, and I'll come back to that, you know, does that really, should that force us to do testing? Also, Mansour mentioned briefly about packaging. And I give you an example, for example, from the China CDC. China, remember, were very adamant that some of the SARS-CoV-2 was coming in on cold packaging from other countries into China, and their workers may be at risk by touching the packaging. They sampled nearly 3 million packaging surfaces and found 22 samples positive for RNA. Now that's a 0.0073% positive rate on a surface that you could argue has been touched many times, been handled many times in a factory, maybe as part of the factory logistics, as part of the air logistics, as part of the reception at in the receiving country. So, for example, you know, when I look, what is my percentage I'm looking at, and it's probably somewhere between this 0.0073 and the data that Mansour presented in his paper in terms of positive rate findings. So the question is, you know, is it worth doing environmental monitoring, you know, to detect such a small number of positives? And I tried to sort of set up a scenario for, let's say, Nestlé, what we typically would do. If I think I want to look at, for example, high touch points in my factory, and I decide I pick 25 sample sites, and it doesn't take long in a factory, never mind the administrative building of the factory, to find 25 high touch points, you know, and I do that 2 to 3 times a week, for example, and my test costs $100 a test. We can debate what the test may cost. So I'm talking about, in a week, I spend $7,500, for example, to do 75 samples. And even at the 1% positive rate, I really have no chance of finding even one person. It's below 1 out of 75. So the question is, you know, is it worth actually doing that? What's the balance between all the preventative measures that you are putting in place to prevent it versus trying to search for the needle in the haystack, which then I question, what do I do with the result? Because I have found RNA on a surface. What is my corrections or my corrective actions? Because in our factories, when we do environmental monitoring, the key thing is it should inform my corrections and it should inform my corrective actions. What do I do with that? If I find a positive, do I then go and start to screen all of my employees, all the contractors, look at all the packaging deliveries, look at all the raw materials that have been delivered, etc., knowing that it could even be from a product that's been pasteurized or heat treated, kill the virus, and I just have RNA. So that for me is always the difficult thing. Is what do I do afterwards, even if I find a result? So that sort of, I'm trying to sort of just paint a picture of what it would mean, and this is, I'm talking even about Nestlé, who can do this amount of testing, but even for an SME, for example, or a restaurant or a retail store to do this, it's this balance between doing this amount of testing, you might say, if I jokingly say, it's easier to put a bag of disinfectant wipes beside every high touch point screen and make sure that it's cleaned after every 5-10 minutes. It might be money better spent in that way. And anyhow, we're doing verification of our cleaning in our factories through ATP verification or whatever anyhow. So we're doing a lot of verification of our cleaning processes already. But then, the food organizations, we look for what is the recognized opinions globally and from food safety authorities on this. And if I take just some examples, there's a recent paper published in the Trends in Food Safety and Technology, and again, you see highlighted, however, especially the sampling kits are rather expensive, making it difficult for their broad application in large facilities of the food sector. So again, they point to the economics of it. ICMSF, which as Ben has said, I'm a member of, again, we do not advocate environmental testing. Even if you look at some of the Q&A for the Cornell calls, again, not advised. You look at, for example, the New Zealand, Australia Food Safety Science Research Centre, which really advises the Ministry of Primary Industry in New Zealand. Again, they're advocating not recommend it, and they say it's better to put your money, let's say, or your resources into preventative measures. So that's just a just put those montage of opinions from external together, so you see that it's not necessarily my personal opinion, but there are other organizations that sort of support this sort of notion. So really, in conclusion, I think we all understand SARS-CoV-2 is not considered a food safety issue. In my opinion, environmental monitoring for SARS-CoV-2 and processing established is not really considered necessary, and it begs the questions, what, as I mentioned before, what do I do in terms of my corrections and corrective actions? I think where people have to focus their resources and activities is really on the prevention of either symptomatic, asymptomatic, or pre-symptomatic workers entering the facilities. Then, if need be, even focus on screening through lateral flow or however of factories, workers coming into the factories. If you're in a hotspot in a community where there is a hotspot of SARS-CoV-2, then it's probably advisable to actually screen your workers coming in on a regular basis, as well as all of the preventative measures. And then, as I say, the key thing is to focus on the hygiene, sanitation, cleaning, and I think, as Mansour said, particularly the high touch point factories, which are the higher risk. So that's it, Ben, for me. So hopefully I give you some insight from a Nestlé perspective, our approach.
Wonderful. Thank you so much, both to you, John, and to Mansour for such a fantastic scaffolding to further this discussion. As I mentioned at the start of the webinar, our whole goal here is really just to further this this dialogue, and you both did just a fantastic job. So we do have some questions that have come in via chat and our Q&A function, and so let me start here. This one's for you, Mansour. In your paper, in the IAH paper, you showed 5% plus positive environmentally in receiving areas, but no other areas had more than 2% positive. Can you go into why you think that might be?
This was one particular plant that had an active kind of outbreak in it. So I think I did mention that this was a unique situation. That doesn't, what receiving areas, it's also where you have a lot of truck drivers coming in and people who know other people that are having access. So you may want to consider that. I want to kind of raise a couple of issues. When John mentioned the data from China, just because the lab says that there is a positive doesn't mean that you really have a positive. There could be a lot of contamination issues when you're dealing with RNA work. So, if they ran like 3 million samples and they had a few positives, that could also, be another explanation, as opposed to something was frozen 3 months later and then made it to China and now it's, has viral RNA on it.
Yeah, no, it's a good point, Mansour, because I think it's a bit I didn't touch on, and that is the methodology itself. As I think I would explain that although we do not advocate environmental monitoring, of course you have to be ready. A company like Nestlé has to be ready to do some testing. So we as you know, we do our own testing in-house. So we have traditionally methods available for hepatitis A and norovirus from the past. And we've sat on the ISO groups in developing those methods, including the proper process controls.
Yeah.
So for sure, for virus detection, process control and avoidance of cross-contamination, particularly with RNA viruses, is extremely important. So it's another element which really, I didn't mention in my presentation, but it's something you have to be extremely careful about.
Okay. The utility of this environmental monitoring, one thing that very early on, we got all of our client base to do, we had them for each one of their production facilities to keep track of the counties around them and the level of infection in the community. So, this is a targeted approach that if you now have a hotbed and your levels in the community are going up, you may want to, this becomes a useful tool to monitor, surgically environment. And if you have hits, then, kind of like everyone has to get tested. Another potential use of a method is to look at it as a verification step for all the other things that they are doing. For the processes, for controls and stuff that they put in. These high touch points have a way of, being a very good surrogate for transfer. And so I do see limited, surgical utility, but I agree with what John said that, this should, I don't see this as a routine methodology to be employed.
Great. I'll pose the next question from an anonymous attendee, and it is for both of you. And there's sort of two parts to this. Are either of you aware of any actual documented cases where there was an individual, food employee at a plant where a worker was infected through these high touch surfaces or these fomites? And I guess the follow up to that is, the correlation between environmental positives and population positives from nasal swabs. That seems like there's a clear line there. But the question is, finding particles, does that actually increase the risk of infection in that environment? So again, let me rephrase this. Do we have any examples of these fomites or high touch surfaces leading to infection in food environments that either of you know about?
So let me take it first. The answer is, no. I'm sure there are a lot of people that blame their STDs on fomites, but we don't have a documented case of COVID. The second thing is, again, what we are finding is the viral genome. It does not mean that it's active or infectious. So, and this is something that we, before we accepted samples from any one of our clients, we had a training session and we told them, okay, this is what a positive means. So people would not panic or, overreact. That we have indication that the virus was deposited, in all likelihood is inactive, is non-infectious. And part of the methodology was that after you take your sample, you sanitize the site. The other thing was that, they, at least with our group, we had set up our client base to have 2 hour, every 2 hours, they would sanitize the, high touch point surfaces. Another group was doing the sampling, so we don't really know what they're going, whether they did it before or after. But the points that, tested positive either had been sanitized or were sanitized, immediately after sampling. We had a question or something in the chat about that. John. What are
Yeah,
your-
no, I agree, Mansour, because I say there is no evidence that I'm aware of that where a worker in a plant has actually contracted SARS-CoV-2, COVID, through contact with the surface. And I think all agencies, wherever you look, be it EFSA, FDA, have all, and WHO have said, transmission through surface transmission, is a very, very unlikely source. And I think if you really look at it in terms of, I'd say there's a lot of ducks have to be lined up for it actually even to happen. And it's not about how long it survives on a surface. It's, can it be a route of transmission of surface? Because you imagine someone who is actively shedding a high concentration of virus has to sneeze on a line or touch a line. It's going to be a point contact. Then even if it's live virus, it will probably inactivate over time. And we know that depending on the surface, if it's a porous surface, it'll survive less compared to a non-porous surface. Yes, depending on the temperature, the humidity, also if it's frozen, it will depend. Then if you take those parts of, let's say, exposure, and then you say, well, how long after is someone going to touch that point with their hands, with their fingers, and then actually transfer that to their nose or mouth? And then what is the infective dose even at that? And there's a lot of unknowns in there, but at the same time, you need a lot of ducks lined up for it actually to happen. Compared to the aerosol, like the transmission through aerosolization, close personal contact. And I think the general consensus, even in terms of from an exposure perception, is that is very, very low risk in terms of even getting from a surface. I don't know if that's clear, Ben.
Yeah, it's perfect, and I think that's where certainly our project's been focused as well, and it's always good just to have further insights around that to make sure that there, I think that there's a pretty good level of consensus in the food industry, and especially based on what both of you just answered. I'm gonna switch a little bit, and this question comes to us from Timalayan, and it's not about in the environment, it's about food products itself. And I just want to get both of your thoughts on this. Do we have any sense of cases of contamination of food products coming from the contamination of a production area? And the second question here, and I think you both have just in your recent answer touched on this, but can the virus survive on or in food products for some time? And I think I know how you're both going to answer this, but I want to make sure that our attendees are getting their questions answered.
Yeah, no, so Benjamin, yeah, it's a little bit of repeat of what I had said before. Of course, if you have theoretically, if someone has sneezed on a product contact surface like a belt, for example, and food comes on that surface immediately afterwards, some transfer of the virus can go onto that food. And then you ask the question, well, how long can it survive? And we have done some internal studies on some various food products. And I think it's probably no surprise, and it's in the literature as well, that frozen products, it will survive longer for frozen products. But I think the key question is not how long it survives and whether that poses a bigger risk. The key question is, is food a vehicle of transmission? And as we've just answered before, I think there is no evidence. If food was, I always say, and in Nestlé, one of the areas that has increased the most in sales has been frozen food. Now, if frozen food was a vehicle of transmission, we would have seen the epidemiological evidence based on, and I think it's not just Nestlé sales, but everybody's sales, let's say, in frozen, where people have been storing in freezers for lockdown, etc. The epidemiology does not tell me that even frozen products, where it may survive, is an issue. If that makes sense.
Absolutely. Mansour, anything to add?
No, the same thing. And then, just because we can detect the virus on the surface, again, and these are envelope viruses. doesn't take much to disrupt the envelope and put an end to the infectivity of the virus. So is it possible to find virus on a surface and on a packaging? Yes. Is it going to pose any hazard to the consumer? No. The data does not support that. Theoretically, if someone ingests billions of viral particles, if you put it in a capsule and feed it to a person so it survives, goes inside, there are receptors in the intestinal tract that the virus can attach and infect and get amplification and go come out in larger numbers. But so in theory, could it happen? Yes, but in reality, you will never have that much viruses protected, go inside, make it there to the site where we have receptors.
Great, thank you. So the next question again comes to us from an anonymous attendee, and they ask, do either of you have thoughts on the potential role of air monitoring devices, which seem like they might be more appropriate for an aerosolized airborne pathogen than surface swabbing or testing? Is that something that either of you have had any experience with and investigated?
From my point of view, even in terms of normal environmental monitoring, Ben, as I mentioned before, we don't generally include air monitoring as a key component of our normal environmental monitoring. Having said that, with SARS-CoV-2, because of the sort of the airborne nature of it, let's say, we have looked at, let's say, engineering solutions and potential means of let's say, disinfecting air, for want of a better word. So there's two ways. I say either you dilute or you filter, or disinfect. So we've been looking at could we put HEPA units in environments, for example, as a filtering, but I say we have not applied this, but this is our sort of train of thought a little bit, because we always say increased ventilation. So we talked a lot about recirculated air, what we can do in those sort of environments, where we can open windows, where we cannot open windows, where we can stop recirculation as much as possible and actually dilute with more external air. So our strategy has been very much about more on the dilution side. A little bit we've looked at opportunities for filtration. And again, this is like something like HEPA filters, but to retrofit air handling units with HEPA filters is not as easy as it sounds. So then what do? Do you look for standalone HEPA type filters in a processing environment? But this is, let's say, this is looking at engineering solutions. Or do you fit? We have also looked at things like, do you fit some sort of disinfection, maybe like e-beams or whatever, on your air handling units that could in some way, as the air comes out of the air handling unit, that somehow you can treat it, either by UV, E-beam or whatever. But this is something I think which really has COVID has probably highlighted a little bit in terms of air qualities in production environments. And maybe it's something that we can look at.
Just as a thought. Oh, yeah, go ahead, Mansour.
Okay. We manufacture a cyclone device that can do air sampling. But one thing that you want to consider is A, you have tremendous air exchange in these environments. B, people are masked. So you don't have active, you don't have like 10 infected people, sneezing and coughing. If you had them, air would have been a good mean to kind of get it. But we are excluding symptomatic people. Everyone else has social distancing and masks. In that situation, I don't see utility for that. However, we have manufactured small cyclones that capture air particles and can be tested.
And it just depends on the environment as well. We have situations where you have process control rooms which are not open to the outside. So, that's a closed environment. We have areas which are like freezer rooms, coffee freezer rooms, or ice cream freezer rooms, which are low temperature. People normally have to wear PPE to even enter these from an occupational safety perspective. In fact, this was some of the things we had to deal with originally, because even normal mask, going in with a normal mask, a face mask or a PPE mask, surgical mask, if you get condensation in your mask, this can freeze to your face. So how do you deal with that? And that's a bigger occupational risk, almost putting a mask on. So I think you have to sort of assess each environment, Ben, in terms of what measures can I put in place around sampling to verify, but in terms of treatment, disinfection, dilution, filtration, etc.
And as a quick follow-up to that, John, you mentioned HEPA filters, and we hosted a webinar a month and a half ago on air filtration and MERV filters as well. Are you aware, or have you guys looked at trying to recover virus from those filters at all? So if there is a filtration process that's happening as a warning process of if we're going through this dilution, can we actually get the virus particles out of those HEPA filters at all? And I think that was the follow-up from the anonymous asker of the question.
Okay, no, what I say, we have not sort of like really implemented HEPA filters in general. Let's say more as a trial. Let's say to see would it work. And then, of course, HEPA, by its nature, will not necessarily filter the virus, but it will filter particles that the virus may be on. That's the idea. So it will generally be attached to a dust particle or whatever, generally, or an aerosol. So that's what's trapped. But then you come back to the question of when do I sample my HEPA filter? Because it will be, as it deposits on it, it will be almost dying immediately. And depending on the nature of the HEPA filter, if you sample after 2 days, you find RNA, but in fact, yes, it's dead RNA. But does it give you an indication? It's a bit like the sewage monitoring schemes that people have done for cities and airports. It might give you an epidemiological picture of maybe what was there to some extent. But what do I do with the data from a food manufacturer's perspective? But no, we've not actually analysed, we've not actually looked at sort of swabbing of HEPA filters.
That's good. Yeah, and again, just I think as both of you have looked at this really heavily over the last 18 months, these are the types of questions that people have who are somewhat, I guess, new to this. Mansour, any other insights on that?
Yeah, it's not worth it. I mean, if you want to do that, you have to do destructive testing of the HEPA filter, and there's so much air going through that. It wouldn't surprise me if you end up with a positive hit, which would not tell you anything. That all it means is that someone sneezed in your building, or air. You don't know whether it came from the air from outside, from whether it generated inside your system. I don't see much value in that.
And it comes back a little bit to your sampling we talked about earlier with Mansour, because I know certainly with the China authorities that said, oh, they are testing finished product. And I had the question is, well, how are you testing finished product? What is your sampling regime? Are you doing this with solid product? Are you doing it for liquid product? And then it turned out in some cases, most of it was by swabbing of a carcass, like of a salmon or fish. So it was swabbing actually. Because then when you talk about, how do I test a powdered sample, a milk powder sample for SARS-CoV-2? The methods are just not there. And you're really trying to, when we looked at this ourselves, you're trying to extrapolate from what was done for Hep A and norovirus. But really you're into a whole new, validation of the method almost in terms of your sampling. And it's a little bit, how do I sample a HEPA filter? Do I destroy it, as Mansour said, destructive, or do I swab? And how much of it do I swab in terms of surface area? So there's always a lot of questions, no matter which avenue you go down about sampling or testing. Not only what do I do if I find something, but even how do I sample? always comes up as well.
Yep. Yeah, absolutely. So, Mansour, this is a question that came in that was specific to the data that you showed. The high touch samples, were they taken pre or post cleaning of the areas swabbed? If it was post clean down, was there a contact time of the disinfectants used? And could you talk a little bit about maybe the metadata around that data set that you're aware of?
Yeah, so they all had this, frequent cleaning of high touch areas, but the people who were taking the samples were independent, another group. So there was no coordination. The places where we were finding it, then it depends on if they were using a bleach-based sanitizer, then bleach would destroy the entire genome, you would not get a signal. But if they were using an alcohol sanitizer, it would inactivate, but it would also fix it to the surface. So with alcohol-based sanitizer, you could get a signal potentially after sanitation. With bleach-based sanitizer, you would not. That's all I can say. But we don't really, they didn't have coordination between the two. And it was possible that, they sanitized and then someone else touched the area.
Yeah, and it wasn't really the design of the study was to understand that. It was really a snapshot of what was there at the time.
Exactly. So,
yeah, great.
And I think this disinfection story as well, Benjamin, just to sort of add to that, because in February, China moved from sampling of frozen products to all products going to China, and all products going to China. You had to have the containers, the transport containers, disinfected as well as the outer packaging. And overnight, we had introduced disinfection and supplied disinfection certificates. And this was a little bit our concern. Even if we disinfect the containers and the packaging, and someone swabs at the other end, and if we have used chlorine-based disinfectants, which basically, or not chlorine, but, some of their quats or whatever the other cleaning agent, peroxide acetic acid, that really might have no effect on the RNA whatsoever, then someone still could find RNA at the other end, despite the fact we've actually disinfected, produced a disinfection certificate. And, what does that mean as well? So these are, let's say, some of the challenges that certainly I had to try to go through, because people asked me the question, well, they might still find RNA, what do we do? And of course, it's a legitimate question, depending on the cleaning agents you have used.
Yeah, absolutely. And it really adds to the practical aspect of that request of what is it telling us and how is it not telling us anything? I guess, general question, and Mansour, you might weigh in on this first. We've talked a lot about sort of the limitations of sampling around finding viral RNA. Are either of you aware of anybody who is developing sampling approaches to look for infectious virus particles? And the follow-up to that is, in a magnitude of cost, we've talked about anywhere from $20 to $300 per sample for viral RNA. I mean, what kind of are we talking, like $1,000 test per swab for infectious virus particle? Like, what would that look like if someone wanted to move into that area?
Yeah, first growing the virus takes you to biohazard level 3. So it's not feasible. It's only done on like a very limited number of studies. And it doesn't tell you anything, because then you are going to get a lot of false negatives, because you take a sample, it's not growing just because the virus particle became inactivated, but the virus particle was there. Our assumption is that we are looking at whether the virus was deposited. And if the virus was deposited, it's highly likely that that is now inactive after a few hours, okay? And even if it was active, then there's a coefficient of transfer from your hand to a surface, and back from the surface to your hand. And then if it gets on your hand, then, transfer again from your hand to your mouth or nose, okay? So that's why it's the likelihood of contamination or infection continues to go down. I don't see any value in looking at viable viral particles, okay? But if you want to do that, it's going to be very expensive and it's a biohazard level.
Yeah, no, we have done some in our R&D side of things, Ben. We have done work on the real virus, on SARS-CoV-2 and its surrogate, but that's more or less looking at, as I mentioned, survival on different surfaces in different foods, but also looking at what proclaimed antiviral coatings, and to see, because there's a lot of adverts out there, be it not name the commercial names, but they're either impregnated with silver or quartz spikes or copper or whatever. So, to do that really thoroughly, we've had to use the SARS-CoV-2 and the surrogate. But that's done as an R&D type project in a BSL-3 laboratory. There is, you imagine trying to do that for every diagnostic test you do as part of environmental monitoring. Firstly, by the time you'd get your data, your products should be out the door, or your employee could have recovered even if they had SARS-CoV-2. So it's even it's a cost, the facilities, the infrastructure that you would need to do live infectious viruses, proof outside of R&D, to do it as a normal operations. This just would not be feasible, because of the time delay, the cost, and the infrastructure needed.
Yep, excellent. That's what I wanted both of you to touch on. That was fantastic. We're getting close to the end of our time. I'm going to just end on one last question. And if you were, and hopefully this is a really fair question, but if you're a company, some of the attendees of our webinars are small, medium-sized businesses. They're supplying lots of products throughout the world and domestically here in the US. But if you were a company who is being asked by either a regulatory agency or a buyer to conduct environmental monitoring, what do you tell them? How do you engage in that conversation? Because I think we've just spent sort of an hour and 20 minutes talking about the limitations and why it's probably not very useful. But how do we engage in that conversation with someone who's asking me for it?
Okay, let me.
I just showed my second last slide, Ben.
Yeah. Guys, when a lab owner tells you that you really don't need to do something, kind of like just take it that it is the truth. So I know for a fact that regulatory agencies here are not asking for this. If a customer is asking, they want you to check a box. Tell them to grow up. If they don't, then you need to check a box, and it becomes the condition of trade, like many other nonsense that we have to do in this business.
Yeah, no, and I think, Ben, as I say, I would show them, firstly, I would say it's not just necessarily my opinion. Look at the opinions of the one I mentioned, my second last slide, ICMSF, scientific literature, MPI, Australia, New Zealand, I have not seen anyone coming out yet saying this is something that actually should be done and will bring benefits. So I'd try to use not necessarily my own argumentation, as we've discussed today, but point to these other ones first. And then I would actually go and say, this does look at the cost benefit. This comes with a cost. This is not like doing EB or total count to show your hygiene in a factory that can cost you $10 a test. This is a complex test, kind of cross-contamination issues. It's going to cost you a lot, and someone has to pay for it somewhere, either in the product or whatever. Someone has to pay for it, and then what would I do if I find something? And this is always the dilemma, even when you're really almost in a corner, like, for example, for China authorities or whatever, where it's a license to operate, you maybe don't have a choice. then you have to sort of, you'll say, you try to convince as best you can, even an authority, to say this is not something that we consider necessary, and you consider, well, what do I do with my product afterwards? What are the consequences then for that as well? Because this is what you have to bear in mind. I don't want to start testing my finished product for SARS-CoV-2 knowing, does that mean a recall? So you always have to be aware of the consequences as well. What will you do? And as Mansour says, if it's a tick the box, one thing is ticking the box, but you will have to think, what's my corrective actions, or what's the consequences for the product, for example, of finding something?
Oh, absolutely. I couldn't agree with the two of you any more. Please accept my thanks on behalf of our project and our attendees today for sharing your insights. This is just a wonderful webinar, and I really appreciate your time and the work that you put into sharing this with us. So John, Mansour, thank you so much.
Yeah, and if there's any follow-up questions, Benjamin, people can, I'm sure, come back. For me, certainly, I'm sure for Mansour, if there's any burning questions around what we have said, by all means, I'm open to.
Wonderful, thanks. We will certainly take you up on that. Just as a way to wrap up, next week we actually have another Food CoVNet webinar. This one focused, sort of, I guess, part 2 in a series here, focusing on international and trade perspectives of SARS-CoV-2 in food settings. And so expanding a little bit on what John and Mansour talked about on some of these regulatory and import and export concerns. We'll have Lori Rouvet from the AFI, American Frozen Food Institute, Roger Cook from the New Zealand Ministry of Primary Industries, and Jeff Farber from the University of Guelph. And so please follow the link if you'd like to sign up for that. All of our webinars can be found at www.foodcov.net. And then also, we don't have a full announcement, but we will be hosting a discussion with WHO and FAO on June 2nd. And so look for more information about that webinar. It'll be June 2nd at noon Eastern time. And again, looking at sort of international approaches and managing transmission in food environments. So thank you very much for joining us today. And again, just a wonderful thanks for John and Mansour for their insights.
You're welcome.
Thanks.
Thank you very much.
Bye-bye.